So this is the chain rule applications lab, and the number one section or the first assignment is 1 through 32. So I'm going to start with number 4, and they look like some of them are evens. I'm just picking the ones that I think are a little bit tricky. And the other thing is, if this really bugs you about having things out of order, do this with me first, and then go back and do number 1, 2, and 3. Okay. So here is number 4. I have f of x equals 4x squared plus 1 to the 7th. The first thing you have to do is recognize what your outside or your mother function is. What is the outside? And I look at it, and the outside looks like I have something raised to the 7th power. So that means that's a power function on the outside. And then that helps me how I start my derivative. So I'm going to start doing this. So I'm going to do f prime of x. It's a power function, so I'm going to do 7 times, and I don't touch the baby. So you don't touch anything inside, to the 6th power. Okay, so that's the first part. Now I have to multiply it by the derivative of the baby, or the baby is the derivative. And I look at it, and the derivative of 4x squared is another power function, so that's 8x, and the derivative of 1 is 0. So I just use the chain rule to do that derivative. Okay, then after you finish doing that, then basically all you're doing now is kind of fixing it up and making it look good. So I'm going to do the 7 times 8x because that would make it look nicer. 56x, 4x squared plus 1 to the 6th power. And so that's how I'm going to leave it. That is going to be my answer. So you're going to copy down the function and look at what the outside is and then do the derivative. Okay? Now they get a little more difficult, so we're going to go to 6. So 6, I have f of x equals radical e to the x plus 1. So I put a radical in there. The first thing I did was kind of rewrite this to the half power, because then that helps me realize how am I going to do the derivative. And then I again realize, oh, I can use the power rule. This is actually a power function as my outside function, or my mother. So I'm going to do f prime of x. I'm going to do the derivative of the outside, or the derivative of the mother. So it's going to be 1/2. Don't touch the baby, raised to the negative 1/2. That's the outside, times the derivative of the baby. So I'm going to go inside and do the derivative here. And the derivative of e to the x is e to the x. And the derivative of 1 is 0. And then basically I kind of rewrite it. Now you'll see sometimes on the answer key, I'll rewrite it, putting the radical in the bottom. The main thing I like, so see this right here, see how they're all factors, is I like it in factored form. So I'm going to just put that e to the x in the front. So that's going to be 1/2 e to the x plus 1 to the negative 1/2. You could rewrite it and put that as a radical down in the denominator next to the 2, but it's not necessary, and that would be perfectly fine, is to leave the derivative like that. Sometimes we do rewrite it. I'll make sure that you're comfortable knowing when and when not to, but as of right now, I just want to make sure you know how to do the derivative and manipulate it a little bit so it's in factored form. So that's 4 and 6. Okay. Next one I'm going to do is 8. And 8 is h of w equals the parentheses w to the 4th minus 2w, all raised to the 5th power. Again, I look at this and say, okay, the outside is the power function again. So this kind of helps you get started. So I'm going to do h prime of w is 5, don't touch the baby, to the 4th power, times the derivative of the inside. And when I do the derivative of the inside, and you really don't need this multiplication sign because it's going to be a binomial, is the derivative of w to the 4th is 4w cubed, and the derivative of negative 2w is negative 2. So I just have done that. Now, the only thing I did different on this one to make it a little bit nicer in factored form is I noticed right here, I could factor a 2 out of this one. Okay, because this one's to the 4th power. So I factored a 2 out. So I've got 10. And then when I factor a 2 out of this one here, I have a 2w cubed minus 1. And then I write this one here at the end. Now, in actuality, it doesn't really matter if these are in different order. I just kind of threw that in front because I factored out the 2 and wrote it like that. But basically, that's perfectly fine of doing the derivative. So that's number 8. Okay. I keep checking the time so that I don't make you late. All right, so here's the next one. I have f of x equals. Now I look at this one and I can clearly see as my outside function, or my outside, what I have going on here is I have a function times another function. So I have to do the product rule. Now, just remember, when you do the product rule, you can do the chain rule within your f and g's. So I see this is an exponential function, and this is a power function and another exponential function, but it will take care of itself when I throw in the product rule when I set up my f and g's. So my f is going to be e to the 2x. My f prime is the derivative of the outside is e to, rewrite it, e to the 2x. And then I take the derivative of the inside, which is this. So it's going to be times 2. So f prime is really 2e to the 2x. That's the derivative. You did the chain rule within the product rule setup, the f and g's, okay? G is x squared plus 5 to the x. G prime is going to be 2x plus 5 to the x ln 5 because that's another exponential function. So within that setup, that's why I like doing f and g's, because it gets you all set up that now I can just plug it in the product rule, and I basically did the chain rule inside of that. Okay, so I'm going to change the color here. So I've got f prime of x is going to equal f prime g. So I've got 2e to the 2x times x squared plus 5 to the x plus f g prime. So I have e to the 2x times 2x plus 5 to the x ln 5. Okay, so that's not really that pretty, but it's not bad. All right. Now I'm going to look at, I have a term here and a term here, and I want to see if there's something I can factor out. And the easiest thing that I can factor out right now is e to the 2x. So I'm going to factor out e to the 2x. So I have e to the 2x I can take out of both. When I do that, so I'm going to do a bracket, and I'm going to go slow. So I have 2 times x squared plus 5 to the x. Okay, that's a 2 right here, guys. All right, plus 2x plus 5 to the x ln 5. All right. And the only other thing you can do is you could probably carry this through 2 through and make it 2x squared, and then it's 2 times 5 to the x. But that's like a little uncomfortable because a lot of people want to say 10 to the x, and it's not, because you don't have the same base and you don't have the same exponents. When I looked at the answer key of this, when I first did this, what they did was they carried it through, and then they had different factors inside. I would leave it like that. I wouldn't do anything more with it because then you start feeling more uncomfortable. But what they actually did was is they put the 5 to the x together and factored out that, and then they factored the x out of the other two, which I thought they made it unduly complicated, but it came out to be like this. Please don't worry about this part, but I got e to the x, and then it came out to be this, 2x times x plus 1. So they did 2 of the terms with that, and then they took 5 to the x out of the other terms, and then they had 2 plus ln 5. This is what the answer key was, and I'm thinking I wouldn't make you do that, but I found it interesting, so I thought I'd show you that because that's one way they did that. Okay, I'm going to only have a chance for another one, so I'm going to go and do, let's do 17. Okay, so I'm going to go back and fill this in with another video, I think, because I want to do the last two. But for 17, I look at this and I see, oh, okay, I have t, this is f of t, so I have a function times another function. So if I set up my f and g's, I can do the product rule when I'm done. So I have f is t, f prime is 1, G is e to the 5 minus 2t. G prime is rewrite it. Then you have to take the derivative of the inside or the baby, and that's right here. So when I multiply that right there, I'm going to have, because it's 5 minus 2t, you're just going to have a negative 2, because the derivative of 5 is 0. Okay, so then I have g prime to be negative 2 e to the 5 minus 2t. Okay, and then we can start setting up the product rule. So I have f prime g e to the 5 minus 2t plus fg prime, which makes it minus because there's a negative, fg prime. So I just put the 2 in front of that t. And then I just basically factored this, and I looked at this is a term, and this is a term. So I took out e to the 5 minus 2t. And when I took that out, I had 1 minus 2t. So that's in factored form, and that's kind of how I'd leave it. So I wanted to do more, so I'm going to stop this video right now, and I'll continue on later on to make sure that it's done.